Hello everyone, this is INE Foundation Lab 3 and section 5.2 eBGP. Okay, let me review BGP concept and I will come back and conclude this section. Okay, BGP port number. As we know, BGP uses TCP port number 179 and it is this port is designed for establishing TCP connection between BGP routers to exchange routing and reachability information across different ASs on the internet. Another BGP feature is eBGP Multihop. Before I explain this feature, let me explain update source first. Then I will come back and explain this feature. Another BGP feature is BGP Update Source command. By default, BGP establishes session using the IP address of outgoing interface or the interface closest to its neighbor. And for some scenarios for redundancy in our network, it is better to use Loopback interface instead of our outgoing interface as source. We can change this outgoing interface to our another interface, for example, Loopback tunnel or tunnel interface by this BGP Update Source command. Is eBGP Multihop. By default, eBGP requires two routers to be directly connected. Because eBGP routers uses a TTL or time to leave value of 1 for the BGP packets. If TTL is 1, eBGP connectivity uses TTL value of 1 to make sure they are directly connected. If the BGP neighbor is more than 1 hop away, then the TTL will decrement to 0 and the packet will be dropped or discarded. 1 minus 1 equals 0 because it is more than 1 hop away. eBGP Multihop is a feature that allows two BGP routers to establish a neighbor adjacency even if they are not directly connected. When eBGP Multihop is set to a TTL of 2 or more, then the disable connected check feature is implicitly enabled. Okay, the disable connected check command is another way to overcome this directly connected feature. We can either use eBGP Multihop or disable connected check command. But if we use eBGP Multihop, this disable connected check command is implicitly enabled on the router. And the eBGP Multihop is used to increase the TTL of TTL value, to increase the TTL value, then so that we can have eBGP connectivity, even if they are not directly connected. This is the eBGP Multihop command. We simply use neighbor, remove IP address, eBGP Multihop, and specify 2. The disable contact check command, as I explained before, we can use either disable contact check or eBGP Multihop. By default, eBGP peers must be directly connected for peering to take place. Then the disable contact check command is used to override this behavior. This command is particularly useful when we want to create BGP peering redundancy using our loopbacks. As I explained before, we can use update source and specify a loopback for our eBGP connectivity. Then we can use either eBGP Multihop or disable contact check command for eBGP connectivity. If we want to change our outgoing interface to another interface, for example, loopback or tunnel interface. Okay, another BGP feature is AS number formats. There are two types of AS numbers in our BGP. One is 2-byte AS number and the other one is 4-byte AS number. 2-byte AS number ranges from 1 to 65,535, and 4-byte AS number ranges from 1 to this number. And we can represent this 2-byte and 4-byte AS numbers in two ways. One is in AS plane, and the other one is AS start. AS plane represents both 2-byte and 4-byte AS numbers as a decimal value. For example, this one and this one. The newer one is AS start. AS start represents 2-byte AS numbers as decimal value and 4-byte AS numbers using the dotted notation. For example, this 2-byte is represented as a decimal value, and this 4-byte is represented as dotted decimal. And the default notation is AS paren, which translates the 32-bit binary AS into a single decimal value. We can change this AS paren to AS start by this BGP AS notation command under BGP configuration. And in AS start notation, a 4-byte AS number is represented as a 2-byte value separated by a dot or period, and it breaks down 32-bit AS into a 2 60-bit section separated by that. The left side is represented as higher value, and the right side is represented as lower order. This is higher order, and this is lower order. And this AS numbers in AS paren becomes this in AS start, and this value in AS paren will become this value in AS start notation. It is higher order 60-bit value, and this is lower order 60-bit values. And we can change this behavior from this default AS paren to AS start by this command, BGP AS notation command. Okay, let's quick review iBGP and eBGP and what are the differences between these two. The purpose of these two, let's check the purpose between the iBGP and eBGP. iBGP propagate routes within the same autonomous system. As we know, to configure iBGP, the remote and local AS numbers should be the same. And eBGP is used for propagating routes between different ASs. And to configure eBGP, remote and local AS numbers should be different. Okay, route redistribution. iBGP does not allow for route redistribution, but eBGP supports route redistribution. To understand this route redistribution, let me explain iBGP rule, or it is also called a split horizon rule. Okay, what iBGP rule or split horizon rule says? It says by default iBGP does not propagate routes learned via other eBGP neighbors. In other words, in iBGP, routes learned from one iBGP peer are not automatically propagated to other iBGP peers, and it means there is no iBGP to iBGP route advertisement. This is how split horizon rule. This is what the split horizon rule says. Let me explain on this picture. As BGP routes as split horizon rule says, BGP routes routers do not advertise route leading from iBGP neighbor to another iBGP neighbor. Here, there is iBGP connectivity between RTRA and RTRB, and eBGP connectivity between RTRB and transit router, and iBGP connectivity between RTRC and RTRB. Split horizon rule says that there is no iBGP route advertisement between another iBGP. If this transit advertise its route to RTRB, because it is eBGP, then it will advertise to RTRA. It will also advertise to RTRC. This is normal BGP behavior. This is RTRB will propagate routes from A and C. We also propagate routes from transit to A and C. Also it will transit. If I see, this is another way. If RTRA advertises to B, then B will transit it to transit, and if RTRC advertises it to RTRB, then RTRB will advertise it to transit. But if RTRA advertises it to RTRB, then RTRB will not advertise it to RTRC. This is iBGP rule or split horizon rule. RTRB will not propagate routes from A to C or vice versa. And check the other way. If RTRC advertises routes to RTRB, then RTRB will not advertise it to RTRA. This is how split horizon rule works. And keep in mind, this BGP internal command is for the distribution of iBGP route into IGP routes, not another BGP. And for this feature, for overcome this feature, we can use the BGP Route Reflector or BGP Confidential. This is BGP Route Reflector, and Confidential is for iBGP connectivity inside our BGP AS. And let's see the topology view of iBGP and eBGP. iBGP requires full mesh topology. It means all routers within the AS must be directly connected. And for simplify this connectivity, we can use BGP Route Reflector and BGP Confidential. eBGP does not require full mesh, and routers can be selectively connected. The difference in topology configuration. And loop prevention, iBGP uses BGP split horizon rule or iBGP rule for loop prevention. As I explained before, this is BGP split horizon rule. And eBGP utilizes AS path attribute. Unlike eBGP, iBGPs do not prepend the AS number to the AS path attribute. Another BGP feature is BGP Synchronization rule. BGP synchronization ensures that BGP routers do not advertise a route to an external BGP or eBGP neighbor until all routers within the same autonomous system have learned about that route via an IGPs or static route. In other words, BGP waits until the IGP, for example OSPF or eRGP, has propagated the route's information within the AS before advertising it to externally or advertise to another eBGP neighbor. Simply, BGP synchronization rule says that BGP router will not advertise to another eBGP neighbor until the BGP length until all routers learn about that route via IGPs or static route. This synchronization feature is disabled by default in newer Cisco routers. If we want to enable, we can use BGP synchronization command on a Cisco device. And default admin distance, IGP uses distance value of 200 and eBGP uses distance value of 20. And for this reason, eBGP is superior to IGP in path selection. If this is show this path selection attribute, this is BGP attribute and path selection. We have weight, local preference, originate path origin code. This is eBGP path over iBGP path. Prefers eBGP over iBGP learned path. Okay, and route advertisement behavior. iBGP routes received from P can be advertised to eBGP but not to other iBGP. This is BGP split horizon rule. And in eBGP, routes received from P can be broadcast to both eBGP and iBGP. In iBGP, there is no iBGP to another iBGP route advertisement. This is the iBGP route. And local preference, iBGP send the part in iBGP, the local preference attribute is sent as part of the BGP attribute, but in eBGP, this local preference attribute are not sent. And next hop behavior. In iBGP, the next hop remains unchanged, but in eBGP, the next hop is changed to the local router. Okay, let's show here. Okay, there is Loopback. Let's see. And its packet is low. It's source address. It tells it has the source value of 1, 1, 1 in the packet. The source address is 1. The transit will advertise this to B, and its source address of this RTRB is 2, 2, 2, and 2. Then if RTRB advertises to RTRA, it will not change this source address 1, 1, 1, 1, 2, 2, 2, 2, 2. It will advertise this packet as source address of 1, 1, 1, 1. 1, 1, 1, 1 to RTRA. Then this will cause reachability issue in our network because RTRA does not have any information about this 1111 network. Then we have to advertise this network in our BGP, or we can use BGP Next Hop Safe on RTRB router. If I come BGP Next Hop Self on RTRB. Then RTRB will change this 111. We'll change this 111 to 222. Then advertise it to RTR. Then RTR will see 222 value instead of 1111. This is how BGP Next Hop Behavior is working. It's in most similar between eBGP and iBGP. Yeah, eBGP it's advertised to BGP. Then because there is iBGP neighbor, the RTRB will not change this next hop. Then we have to use next hop self on RTRB. Same as on here. If RTRB advertise it to RTRC because it is iBGP network connectivity, then we have to use next hop self on RTRB to change this 111. For example, here is 3033. It will says 3033 and advertise. To change this 111 to 3033 and advertise to RTRC. Okay, another BGP feature is with BGP Route Reflector. As I explained before, we have iBGP rule, so split horizon rule. iBGP will not advertise BGP advertisement learned from if it learns from one iBGP neighbor to another iBGP neighbor. This is BGP split horizon rule. For this reason, in our BGP topology or iBGPs, a full mesh iBGP should be maintained within the autonomous system. And resolution to resolve this issue is configuring the BGP router to become a route reflector. We have to configure route reflector and route reflector clients in our network for this full mesh behavior to configure this our full mesh in our network in order to easily configure full mesh in our network. Okay, let me explain BGP Route Reflector. There are three types of BGP peerings in BGP Route Reflector. One is, let me this is I'll pause this video and this. Okay, there are three types of peerings in BGP Route Reflector. One is eBGP neighbor. This is eBGP neighbor. This neighbor to our route reflector. iBGP client neighbor or neighbor between route reflector and client inside cluster. These clients are iBGP neighbors between client inside cluster and route reflector, and we have iBGP non-client neighbor. This is neighbor between route reflector and client outside cluster. This is our iBGP non-client neighbor. And rules, what it says route learner from eBGP neighbor can be forwarded to another eBGP neighbor, client and non-client. Okay, learner from eBGP can be forwarded to client, non-client and another eBGP. And route learner from client inside cluster can be forwarded to another eBGP neighbor, client and non-client either. This is the same as eBGP. Let me clear this. And route learner from client can be forwarded to another eBGP, another client inside cluster and non-client outside cluster. This is how eBGP. This is how it's learning from eBGP either. We can change this client to client if we want to change this behavior. If we want to disable this client to another client reflection, we can use no BGP client to client reflection command in our BGP. This no BGP client to client reflection command will disable this client to another client reflection. And third rule is this one. Would learn from non-client or client as a cluster can be forwarded to another eBGP neighbor. Client is a cluster, but not client as a cluster or non-client. Yeah, it's if I receive with a non-client as a cluster, it can be forwarded to another client in a cluster. eBGP it can be forwarded to another eBGP, but not a non-client as a cluster. This is normal iBGP rule. There is no non-client to non-client with advertisement in iBGP rule. This is how normal iBGP rule says. No client to non-client with advertisement. For configuring with reflection, to show easy to become. If we want to compare one water to become route reflector, we can simply use this command. Enable IBRTS route reflector client. But on the client routers, there is no any configuration. This command is we can configure this command only on route reflector itself. And for verification, we can use show iBGP, and there are two BGP attributes for reflection. This is originator ID and cluster list. The job of originator ID is that the originator ID is a set by route reflector, and when iBGP router receives a route with its own originator ID, this will not accept the route. It will drop the route if it's its own originator ID. If we type show iBGP and see its own originator ID, it will drop the route. Another one is cluster list. The cluster is used to is the router ID of route reflector, and whenever route reflector sees its own cluster ID, it will drop the route either. And if we see more than one cluster list or cluster ID in a cluster list, it means we have more than one route reflector in our network. Let me show this. Okay, in previous section I have configured RT as route reflector. I have configured between a spoke and R6. Okay, yeah. In previous section, I have configured RT as route reflector, and RT is DMVPN hub either, which is this hub. Then two is spoke, one is spoke, and 7 is spoke, but 6 is not a spoke. Then I have configured below. I've configured BGP Dynamic Neighbors for more DMVPN connectivity, This is, let's show, this is our upcoming BGP Dynamic Neighbor and Route Reflector. Oops. Our upcoming manual neighborship between 6 and R3. These connectivities are the concrete connectivity in the DMP network as dynamically. Let's do this. This is dynamic neighbor, dynamic neighbor, and this one is a static neighbor. Let me show this. This is R3. This is water BGP. We have created peer group for my DMVPN networks. This is create a peer group, a group name, and I have used update source as tunnel and remote areas. Then I have used a BGP listen range for our tunnel network. And I have used, because I have create this command, no BGP default IP with unicast, then I had to conquer this peer group on the this address family command. Address family before I have created. I have used a BGP peer group for Route Reflector clients for DMVPN spokes. Then I have activated this. Then I have created manually neighborship between 3 and 6. So neighbor. Then I have activated this neighbor and used Route Reflector clients. Then 6 and other routers are Route Reflector clients. Yeah. 6 is Route Reflector client. 2 is client. 1 is client. 6 is client manually, and 7 is client either. Then I have created Route Reflector on R7. This is another Route Reflector. And I have used R5 as Route Reflector client of R7. Let's open show this. Showdown type section for the BGP, and R5 is our client. Now 6, then for 6 I type this R5 right there. Then I have advertised loopbacks. I've created new loopbacks and advertised it on my network. And if I tap this one, now 6, show IP BGP, show, let's see new command, new one, show BGP IPv4, unicast, and this value, then there is 2 clusters here. This is 3 and this is 7. The cluster list, I have the 2 IDs in cluster list, then there is 2 Route Reflector in our network. Okay, another BGP feature as I showed in the lab is P group. We can create P group by simply, as I showed experiment here on R3, we can create P neighbor iBGP, then specify this is a P group name, then specify P group. Then I add the P group parameters like remote AS, update source, and so on. Then I upload this P group by this command. Remember P group name. Then I update as in this one. On the others family, after advertise this P group on the others family because I have used no BGP for that before dash unicast command. On the others family, I've used first I have to activate, then use neighbor iBGP P group name and with the client just another parameter and activate it. Another BGP feature is BGP templates. I will not gonna explain this one to another scenario. BGP Dynamic Neighbor, and we can use BGP Dynamic Neighbor instead of manually. We can advertise neighbor either by dynamically or manually. Yeah, on R3, I have used dynamic neighbor advertisement for our DMVPN network by BGP distance range command. I have used a BGP distance range command, and this is our DMVPN network range and length and P group and P group name. If I do show IP BGP summary, it says dynamically created based on listen range command. These are all dynamic DMVPN networks, and this is manually concrete. Okay, let me explain last BGP concept and go to software lab. Another BGP concept is BGP conditional route advertisement. We can use this BGP conditional advertisement uses exit maps or non-exit map or both. We can use both this together map respectively in conjunction with advertise map. It uses basic if and then logic. If we can say if route exists, route x is in table, we can specify this by route map and use exit map. Exit map means the route is in our table, then advertise this to appear. And okay, now let's configure this section. Configure R9 in AS 900. Let's see topology here. This R9 is BGP AS 900. And WAN and R9 should pair using the Loopback 0 interface. It means we have to change the default outgoing interface behavior by update source. We have to use update source here, and do not use eBGP Multihop because there is eBGP connectivity. There is eBGP between 9 and R1. Then we have to use update source. Let's see here. update source loopback 0. Then because this is eBGP, then we have to use either eBGP multihop or this command. Or disable connected check. Here instead do not use eBGP multihop or TTL security. It means we have to use, or we should use, this command here. Disable connected check instead of eBGP multihop. So disable connected check here. And authenticate the BGP session using password of this one. Let's see this part. Let's do this here. I simply open 9 and configure BGP here. So I'll configure BGP now 1, showdown, subsection, rotate BGP. Okay, config T, rotate BGP AS 900. Then I have no BGP default here. BGP AS notation dot. Then I have to use neighbor loopback. Let's see, show IP interface brief. Loopback is 1111. Then I have to type neighbor 111. Remote AS is AS dot notation value. This one neighbor, then I have to, because eBGP, I have to update source loopback 0. I can use eBGP multihop. I have to use disable connected check instead of eBGP multihop. I'm gonna have to give password. Password is this one, BGP CCIE. Let me configure this on the other side. Do showdown type section rotate BGP. This time should be neighbor 9999. Limit AS should be 900. This 999. 999 password is not updated, so it will pass 0 either. config t what a BGP this one. Oh, I have to activate this in address family. Yeah, either no BGP. I go address family IPv4 unicast and tab neighbor. This one activate. Address family IPv4 and neighbor. This one activate. This is BGP port number 179. Sharp BGP summary and our neighbor is up. Okay, let's do another conquer loopback 99 on R9 and advertise it into BGP. Okay, this is the previous section. On. Oops. Exit. Top interface loopback 99. IP address should be 128. This is 1099 9. Nine 255 and create route map. Let's see, I got this short on. So route map contact to BGP and I'll match this. And on the BGP on the address family I have to read this to contact route map and to BGP. Exit with a BGP 900 address family IPv4 unicast and advertise this with map list here. By to show iBGP. Now this is next hop of 0000. It means locally. Okay. Let's explain what is value, why we have next up of 0 here, 0000. In BGP we have something called Originate Attribute. in a BGP path session, BGP prefers path that are local router that the local router originated. Has originated. BGP router will prefer routes that it is installed on BGP by itself or a route that another router installed in BGP. In BGP table, you will see the next hop of 0, next 0, 0. This next hop 0, it means it is locally originated route. It can be installed or advertised in BGP by network command, aggregate, or redistribution. I have used redistribution in this section. And the locally originated prefixes have the default weight value of this one. If I check this value, this is the weight. This is locally originated route. BGP prefers locally originated in BGP. This is because it prefers the path that locally originated. We can use it. We can local originate with either by network or aggregate or redistribution. Okay, but these routes are not locally originated. This BGP has learned this route from another AS. This is another AS. It's come from this AS. It's not. These routes are not locally originated. Okay, let's do another path. This is done. This is done. This is done. And this is done. I have calculated BGP. And last part, R1 should only propagate R9 loopback 99 to its BGP peers when it has a route to R5 loopback. Okay, R1 should only propagate or advertise R9 loopbacks. Let's see topology here. Let me show this here. It says R1 should only advertise R9 loopback 99 to its iBGP peers. This means other peers. This one, this one, this one, and this one. When it has a route to R5 loopback 99. If it has route to R5, R5. Let's see. This one. Okay. Yeah, sure. R1 should advertise R9 loopback 99 to its iBGP when it has a route to R5 loopback 99. Okay, I can achieve this goal by this BGP feature, BGP conditional route advertisement. If R5 loopback 99 exists in the BGP table, then it will advertise this to my iBGP peers. Okay, can achieve by creating route map and type exit map and do with advertise map. Okay, let's complete this feature. Yeah, I have to create two route map, one for R5 loopback. This is my exit map. I have to create exit map, exit map for R5 loopback. And I have to create advertise map. This is advertise for with advertisement. This is advertise map. Okay, let's create R1. Let's create advertise map. IP access dash this. Let's call standard and call this my exist map of 5 loopback 99. Then permit this R5. Let's see if I have this route in my table view. Show R5. What is R5? Choose this value. Oh no. Permit. This is R5. Look back. And type route map. Call exist map and match this one. Okay, IP address. Match IP address. This exist map. And I have to create another route map. It is called for advertise. I have to create an route map for advertise map. Let's create access this IP. Access this, then match my. Then I have to create exit map for my advertisement. Actually, I have to create route map for my advertisement. More, let's see what it should advertise. Then R1 should advertise INE loop and I have to create advertise map and match this INE loopback 99. Access list. Let's say advertise map or non loopback 99. Standard. Then permit my this to show IP interface brief command and permit this loopback 99 and create route map. Route map. Let's say call it I have to try advertise. Open advert. Advertise permit this, then create a route map advertise map, and match IP address and this advertise map, this one. Done. Okay, I have created what I have done so far. Okay, access list and call it exit map and match it this loopback of R5. This is because when it has a route to R5, this is my exit map. Then I have created advertise map. When it has a route to alpha loopback 99, then it will advertise this R9 to other iBGP peers. This is my advertise map. Permit I have created into with my one is exit map, and this I matched this R5 loopback because this alpha loopback has to be exist in our network so that it can advertise to other iBGP peers. Now created advertise map and select R9 that if alpha exists in our network, then it will advertise R9 to our iBGPs. Yeah, and the last section I have to type neighbor. Go into do showdown pipe section. Go to BGP. Under Route BGP, I have to select my to here. This is my hub. Oops. Neighbor, this is my iBGP connectivity neighbor, this one. Then I have advert. I think this is on the address family. I think I have to go on the address family this time. This is for unique. So I have used this command. I have to use on the address family. Okay, advertise map is on the address family. Advertise map and select my advertise map. This one, yeah. This is my advertise map. The like Route Reflector because I have configured this no BGP default IP for unicast. I have to configure this advertise on the address family IP for unicast. Okay, advertise map. more advertise route map. What is one route map of other route map? This is my route map. Then I have exit map and my exit map. Where is my exit map? This is exit map. Done. Then I will advertise on a loopback to its iBGP whenever our 5 loopback exists in sorting table. Let's see if there is show IP BGP. Let's see R5 loopback. Okay, this R5 loopback exists in my network. Then if because R5 loopback exists in my in R1 routing table, then R1 will advertise R9 to its iBGP peers. Let's see. Check on 2. Next check 2. Show IP route R5. Yes, via this and or tail. Let's check tail. Show IP BGP. If the okay, this should exist. Now let's chart this loopback. Config T interface loopback chart. Or before I shot this interface, like no shot. Let's turn on. I type debug IP BGP update on the iBGP out iBGP out. Now let's shut this interface. On our one, it says it's withdrawn. This is update from this one. It is withdrawn. Nobody passed for this network. Let's check. on out to the street for out this path. Do you know the table? Now let's enable this mount. No shot. Okay, this is the match advertise map. This is 101. The condition electricity map changed to advertise. This is how advertise is working. Now if I check on R3 or R1 or R1 or R2 account, now the what is existing my BGP table. This is how advertising is working. Can verify this advertisement here. This one. Condition exit map changed to advertise. The net is never matched advertise map and advertise map bomb version 215 and so on. You are okay. That's it. This is how BGP conditional advertising is working, and I hope you have enjoyed this video and thank you for viewing.